All right, section C, module 3, which is operating systems and computer networks. 4 marks to distinguish between batch processing and multitasking system. Give one application each of them should use. So they want us to give one application. That means you have to give an example. When you're doing this, I don't know, there are a lot of lines to write on, but as far as I know, they don't really look for, you don't need to write a whole paragraph for it to make sense. You probably just want to say batch processing runs the program code from start to finish and no other code can run. Example, easy example would be payroll. Payroll or accounting procedures. Multitasking allows for multiple programs to run on the same processor by splitting the processes splitting the time each process gets. Into time slots. Example, whatever you're doing, like playing music, and I don't know, playing music and drawing a sketch. Just think of any two things that you do on a computer at any point in time, right? Cool. Differentiate between each of the following pairs of terms: polling and interrupts. Okay, polling checks devices to see, excuse me, if they need CPU time. Interrupts send messages when they need CPU time. Right, yes, buffering and spooling. Buffering and spooling, they're almost the same thing. I don't understand why it's so different, but okay. In order to spool, you need to be able to buffer, right? So buffering is storing data temporarily in memory for future use. Spooling is storing data or an input-output device for future use. Yeah, I would put it like that. Store it for, yeah, input-output device. It would hold the data there temporarily for future use. Okay. Briefly explain how an interrupt is handled by the processor. Okay, step 1. The interrupt signals the processor saying it needs to run, saying the process needs to run. Step 2, the processor puts the current process in the ready queue. 3, the interrupt runs the completion. And 4, the preempted process goes back into the CPU to run. Yeah, that should be format clear. I don't see any issues. We'll see. Alright, diagram above. The term used to describe what has happened as a deadlock. Outline the conditions under which an event must occur. Alright, process A has resource 1. Process B has resource 2. Process B has resource 2. Process as well and won't let go. Won't let go. Won't let go. Right? Process A needs resource 2. Process B needs resource 1. Yeah. Right, so they each have each other's they each have a process that they won't let go, but they need the other process, but they won't let go of the other. So something like that. So they'll wait. State 2 is in which the event depicted in the diagram could be resolved. Well, you have 2 ways that you could solve a deadlock. You could kill the process, kill one of the processes, so it releases the resource. To the other. Or there could be some predefined logic that gives higher priority to one of the processes. Or you might get user intervention. Yeah, we will take that too. User intervention could be accepted. Alright, define each of the following scheduling algorithm. Shortest job first. Processes are organized in descending order. Based on runtime. The shortest runtime gets to execute this. Until completed. Yeah, right. So you organize them in descending order based on runtime. Shortest runtime gets to go first, and then everybody else will just keep running through. Yeah. Round robin. Each process is given a set amount of CPU time called a quantum. When the time is expired, it goes to the ready queue until it gets another quantum. This repeats until it is finished. I think that's it, no? Yep. So that's finished. Alright, defining attenuation as it relates to computer network transmission. This question is keep asking all the time. I'll be like, what? Why they do this for? But yeah, attenuation is the loss of signal strength. Over long distances. Typically happens with electrical signals. Right. Draw a diagram to depict a hybrid network topology. Write a brief description of your hybrid. Alright, so basically draw two types of networks. Say we create a bus that connects to some sort of switch router, and the router here connects to a bunch of a router connects to a switch, and this switch has multiple devices around it, which basically shows a star. And yeah, and then the bus could continue here to another type of network or a ring or something. Yeah, something like that. And you probably want to label this as bus star and then next star. Draw a diagram, write a brief description of your drawing. Right, so this is a bus network with two star networks connected to the bus. Yeah. So any two should be good. Once you do a star on a bus, you can put a ring on a bus if you want, if you feel like it. If you feel like it. Alright, some mobile network technologies provide service through the embedded technology in the mobile device, while others provide service through the SIM card's name and define each of these technologies. What? Oh, This is tough. I didn't think they would ask a question like this. So the embedded technology inside of it is CDMA, and the SIM card is called GSM. CDMA uses code division, multiple access, to transmit information via certain frequencies. GSM uses time division, multiple access, which gives each frequency a certain time slot to transmit. Yeah. Yeah. Global GSM stands for Global System for Mobile Communications, but I guess that they I don't know. Alright, so CDM is embedded. I ain't too sure what they want here, you know. The GSM is the SIM card, but GSM is just a modified version of TDMA. Yeah, GSM is just a modified version of TDMA, so I don't think that it should be much of an issue. But yeah. Alright. Explain what is meant by HTTPS, including responsible scenario where it could be used. Okay. HTTPS stands for Hyper Text Transfer Protocol Secure. That means a secure socket layer is applied to the data that is transferred to encrypt it. Making it more secure. Example, a website that collects credit card data would use HTTPS when transferring files. Right? Cool. Alright, expandability and interconnectivity are important considerations when designing computer networks. Differentiate between these two using one example of each to support your answer. Expandability. The network should be configured in such a way, that you can add devices easily. For example, using a startup topology. Next one is interconnectivity. Interconnectivity is a weird one, man. What would they want for interconnectivity? I don't know. Allowing a network to connect to other networks when necessary. Example, firewall rules to allow certain traffic. Right, interconnectivity will be the firewall is usually where it would allow certain traffic to pass through. Outline what is meant by the term VoIP. Voice over Internet Protocol. Transmission of data that is encoded with voice communication. I don't know what to say about that. Outline what is meant by VoIP. Example, phone calls over the internet. I'm not too sure. Usually when I don't understand, I kind of dumb down the answer as best as I could and give an example. Because they say outline, so for example, and hopefully the examples would be good enough for them to understand that you know what you're talking about, because outline what is meant by the term VoIP. You give the acronym and then what else? I don't know. Yeah. Voice over IP, and it's used to make calls, I guess. Explain why VoIP may be better than traditional phone services. Well, it's cheaper. Once the internet is present. And yeah, and you could also say the quality can get very high depending on the speed. Yeah. All right, we'll take that. This module had some weird questions in it, but you should be able to weather it by giving some examples. But yeah, so that was it there for module 3. Alright, it's that time of the year again where it's time for crash courses, because you spent your whole year fighting up with school, not being able to go to school when you want to, always worrying about COVID, all kind of issues. So I have all the CSEC IT, CAPE IT, and CAPE Computer Science crash courses that you need. I'll be able to give you the whole syllabus in one quick dose to be able to get you over the hump. So here's how the crash courses will be going this year. So for all the crash courses, we have 3 different levels that you could choose from this year. Level 1 is video only. That's just a video that'll be about 6 to 8 hours long that covers the entire syllabus, going through
in a kind of like a speed run, explaining every single thing, but not explaining every single thing, if you understand what I mean. Level 2 is a video and a class in April where you get to ask me anything about the syllabus. So you'll get the video in advance, you could watch it about 2 to 3 days before, and then you come to that class and then you ask whatever question you need to ask. And the third one is you get the video, you get that class, and you get access to our WhatsApp group directly to be able to ask me questions at any point in time whenever you're doing any past paper, whenever you're studying any work. And that's how the crash course is going to run this year. So the crash courses will be CSEC IT, CAPE IT Unit 1, CAPE IT Unit 2, CAPE Computer Science Unit 1, and CAPE Computer Science Unit 2. Those are the days. Each one runs from 9 to 12. That's if you take the class option. You will be able to come into that class and ask any question about the syllabus, and of course you will get the video a few days in advance where you could watch through the whole thing. So what are the costs? Well, for all crash courses, CSEC and CAPE, basic, which is the video alone, will be $150. $200 will be for the standard, and the pro will be $250, which is the video, the class, and the WhatsApp group to ask questions at any point in time. So how do you register? You head to makeITsimpleTT.com/crash course, and you will be able to see all the courses that are available. You choose the one you want, you register, go through the payment, and then you will be given the video. Once you're given the video, you will be able to watch it at any point in time. Of course, if you register for the other ones, you'll be given the video and you'll be given the timetable of when your class is going to be. You'll be added to a Google Classroom. And if it's a pro, you'll be given the video, you'll be given the class, and your phone number will be added to our WhatsApp group. So that's makeITsimpleTT crash courses. So I look forward to seeing you all. April, everything is going to be launched, so you can register from now, which is from March, for them. And you might just get the video before the end of March. And just in case you're wondering, these crash courses cover the new syllabuses. So the new syllabus for IT CSEC that launched a few years ago, the new syllabus for CAPE IT, and the new syllabus for ComSci. All the new stuff, all the things that they put into the syllabus that may not be always clearly explained, or the current textbooks don't have it, these crash courses have it. makeITsimpleTT.com/crash course. So I'll see you all there.